So, grab your controllers and join us on this unique journey as we navigate the high-speed craft CFD analysis with a gaming twist. Fasten your seatbelts and level up together! The subjects of this tutorial will be this paper, aimed to provide information of the effectiveness of the interceptors on the planning hull. There are main dimensions of the ship, setting up computational domain and boundary condition, mass density, the math formula, and the behavior of the high-speed craft with and without interceptor. This tutorial explains step by step how to figure out the effects of interceptor to the trim, heave, drag, and lift force. The results of the numerical simulation study will compare with the experimental data conducted by Professor Park et al. The level of accuracy of CFD provides relevant results to the experiment with a maximum difference of 10.7%. Okay, in this game we have several levels. Let's begin at the first level. At this moment, I'm using Rhinoceros software to design the ship. We can also use MaxSurf, DalShip, FreeShip, or any other software. I'll analyze the drags and 2 degrees of freedom of the ship, such as trim and heave. So, adjusting the XYZ coordinate position to the center of gravity of the ship. The placement of the ship's position will greatly influence the accuracy of the calculations. Before importing to STAR-CCM, try to find the value of the center of gravity from baseline and also transom. The next level is using a second software. So, open STAR-CCM, click Open, parallel on localhost, choose Compute Process into 8, scroll down, find the STAR-CCM format. In this tutorial, I choose a close to chain position with 40% high interceptor. Because of our time limit, we don't have a time to design from a zero or blank file. Instead, I introduce you to the concept of how to create several crucial geometries such as background, oversets, one of simple refinement that we call D3, and also import file. Okay, I delete the fourth component and we're gonna start from the new one. So let's start from the background. Click the right mouse into Part, New Shape Part, Block. In the journal that I mentioned before, I explained how to assign the size of the background. So, read the previous paper to know the history of this number. The dimensions depend on the length and the shape views. In these tutorials, I am using the reference from ITTC's recommendation. ITTC's is the International Towing Tank Conference. After finishing, please rename the new part into background. The same steps also can be used to create the oversets and refinement. Overset mesh is a mesh method using donor acceptor cells. So, because of that, we need to create an overset box and background and also refinements. This method requires more than one geometry with the background as a donor and overset as an acceptor. Let's rename the assembly file into the high-speed drive. A geometry part is a collection of the surfaces and curves that you wish to address as one object. So we need to split it. Right-click the surface node and split by page. Select the part surface page from the list box or from the geometry using the mouse in the current scene's display. Enter the new part surface name. Click Create to create a surface node based on the selected page information. Repeat these steps for all required pages. Click Close when done. Geometry part provide an efficient way of organizing geometry data in preparation for meshing. Part surfaces and curves can be defined with surface mesh data, depending on the type of geometry part. I'm using some research to find the best mesh for my simulations. For more information about the meshing strategy, you can also read this paper for your reference. And then, go to the operation section. We have two parts, background and subtract. Here we set the mesh size for each part that we create above. The goal is to increase accuracy, avoid meshing errors, and speed up computation. Set the base size and then scroll down until the custom control. Custom control override the default control for the areas that you specify. For example, input the curve control from the previous part. Use the curve controls and values to define the mesh control that you want to modify. Anyway, you can see how I set the surface remeshers and also trim measures. The reason is, the surface remesher is able to refine the surface size. Prism layer measures refines the number of prism layer stretching, and prism layer thickness. To include the prism layers, the extent of the volumetric control must exceed the boundary. Trimmed measures refine with either an isotropic or anisotropic cell size. If you specify by option, the smallest cell size in each coordinate direction takes priority. You can apply each volumetric control to any combination of meshing models. Therefore, you can set specific cell size within a zone for each mesh generation stage. The same steps also can be applied at the subtract part. After that, let's move on. Continue. Refer to overall frameworks and structure of the software that allow you to perform wide range of CFD simulation and related tasks. Continue is used to describe the software's ability to handle a continuum physics from single-phase flow to multi-phase flow, turbulent modeling, and more. In this case, I use K-epsilon turbulence, multi-phase interaction, namely water and air, VOF wave and volume of fluids, Reynolds average Navier-Stokes, and also determine the initial condition. First of all, select the basic one and Euler multi-phase. Multi-phase flow is a term which refers to the flow and interaction of several phases with the same system where distinct interfaces exist between the phases. The time phase usually refers to the thermodynamic states such as solids, liquid, or gas. The VOF wave model is used to simulate surface gravity waves on the interface between liquid fluids and heavy fluids. This model is typically used with 6 DOF motion models for marine application. Assuming that the waves are propagating steadily without change, the steady wave problem. The wave trains can be uniquely specified and solved in the terms of three physical length scales: water depth, wavelength, and wave height. The volume of fluids models is the models provide for systems containing two or more immiscible fluid phases, where each phase constitutes a large structure within the system, such as typical free surface flows. This approach captures the movement of the interface between the fluid phases and is often used for marine application. Gravity, specifically including the buoyancy source terms in the momentum equation. The segregated flow solver controls the solution update for the segregated flow model according to the simple algorithm. The K-epsilon turbulence models allow you to compute the turbulent kinetic energy and the turbulent dissipation rates to provide closure the Reynolds average Navier-Stokes equations. If you want to assign multiple parts to the specific regions which boundary-based interface between regions, do the following step. Within the geometry, part nodes, select all the parts that you intend to use in regions. Right-click on the one part and choose Assign Part to Regions. In the Assign Part to Region dialogs, in the lower parts of the dialog, choose the following options. Okay, next step is jump into regions. This refers to the feature that allow you to divide and manage specific domains or regions within your computational domain. In these regions, I will set the background where there are inlets, outlets, and symmetry. In a condition that are far from the field can impose pressure, velocity, and free surface elevation. Outlet condition, this condition requires no inflow from this boundary, so it must be placed for downstream enough to guarantee the struggle of the computation. Otherwise, zero normal gradient over set mass creation is a bit more challenging than the one of the single mass, since it requires the creation of the two computational domains, the backgrounds and the overlapping domain. Regions are a fundamental aspect of setting up simulations, particularly in the case where you need to apply different boundary conditions, mass resolutions, or physics model to distinct parts of your computational domain. The same steps also can be applied to subtract. In subtract, I define the basic value with the axis motion specification with the FBI rotation and translation. And then, clear the solution. Execute the background and subtract. So, wait a moment until the math process is finished. Okay, let's go to create the interface of our set. Interface use to transfer solution quantities between regions in the simulation. Certain type of interfaces modify quantities passing across them. Periodic and repeating interfaces allow you to reduce the scope of the solution domain. Mass, momentum, energy, or any other simulation quantity cannot pass from the other region to another unless the interface is in a place between them. For examples, in the simulation below, a contact interface is present between the solids and fluid regions so that the heat flow can pass between. So many types of region-based interface, however in this case, I'm using the overset interface. Let's move into the FBI. Use the FBI, dynamic fluid body interaction, to simulate the motion of a rigid body in response to force exerted by the physics continuum or to any additional force that you define. Let's jump into the derived part. They are contained within their own nodes in the simulation tree. You create them using the context menu on the nodes. An isosurface is a surface where the scalar function takes on a constant value. SimCenter STAR-CCM Plus allows the creation on isosurface from part compression regions, boundaries, and other parts. Next level is solvers. In SimCenter STAR-CCM Plus, solver compute the solution during the simulation run. Going into next level is setting up the stopping criteria. Stopping criteria allow you to specify how long the solution runs for and under what condition it stops iterating or matching in time. Let's jump into report menu. A report presents a compute summary of the current simulation. The report summaries are usable for post-processing and enable engineering quantities such as drag, lift, trim, heave, or mass flow to be computed. After that, the game will be finished. Let's into the finals. And
3, 2, 1.
at the end of this game, we can see the results of the calculation, the graph, the number, and visualization of the high-speed graph. You can click the plot menu to see the graph. the report for the numbers and also the scenes to know the acting of the ship with patterns and also the scale art. The numerical simulation shows the total direction and motion of the planning hull is a good agreement between previous experimental studies at calm water conditions. The CFD simulation confirmed positive results of applying interceptors on the planning hull. And yes, we win! Wow! Congratulations! Wow! I provide the transcript of these tutorials. You can find the link in the description below. You can also contact me if you have any question about the simulation. Okay, thank you for watching. Have a nice day. Bye bye.